Dear students, the Schlumberger configuration is the method. The method was developed by Schlumberger in 1916. In this method, potential electrodes P1 and P2 are kept at constant separation compared to the current electrodes C1 and C2 for a set of readings. In general, the distance between the current electrodes is equal or more than 5 times the distance between the potential electrodes. The apparent resistivity measured in the Schlumberger configuration with a given formula you can see on the screen, and arrangement is made and shown in the figure. Inner potential P1 and P2 and outside C1 and C2. C1 C2 are current electrodes. With this formula where L is equal to distance between current electrode, B is equal to distance between the two potential electrodes, V is equal to potential difference, I is equal to current sent into the ground, rho A is equal to apparent resistance, that is in ohm meters. In this arrangement, the potential electrodes are kept at constant separation for a set of readings when only current electrodes are moved. The potential electrodes are moved for another set of readings for another set of current electrodes expansion. In both the systems, all the four electrodes are kept in straight line in Veeresh as well as Schlumberger configuration. Vertical electrical soundings VES. In this method, a number of rho A values are measured at the same place by increasing the distance between the current electrodes each time after taking the reading. The successive increase in distance makes the current penetrate more and more deeply. Generally, the depth of penetration of the current is about one-third of the distance between the current electrodes. The essential idea behind vertical electrical sounding is assuming conductivity or resistivity varies with depth. Conductivity and resistivity varies with depth. The apparent resistivity can be determined with the help of Veeresh configuration or Schlumberger configuration. The depth to which current potentials in the ground depends upon the distance between the two outer current electrodes. Thus, it is possible to send the current deeper into the ground by increasing the distance between the electrodes. For accurate interpretation, detailed knowledge of stratigraphy is very necessary. The values are plotted on log sheet by plotting the electrode separation on x-axis and true resistivity values ohm meters on y-axis. The obtained curve is to be matched with master curves. There are two approaches in this regard. One is qualitative and the other is quantitative, which may be get by the interpretation of vertical electrical sounding data. The qualitative interpretation helps in understanding general subsurface information about geological structure of the area and to learn about geological action changes. The quantitative interpretation helps in knowing the lithological variations and thickness of the subsurface layers. In this method, four types of master curves are interpreted depending upon the resistivity variation with depth, that is A, Q, H and K type curve. A, Q, H and K type curves. Out of these four types of curves, the out of these curves, four curves, the H type is feasible. We can expect the water from this curve. Thank you.